So the next thing we're going to learn about is we're going to learn about the histogram as well as the edge tool. In particular, we're going to talk about how we can use the histogram to basically do kind of presence or absence. And then we're also going to talk about fixturing. Okay, we didn't talk about fixturing before because it didn't make any sense. But what I want to be able to do is, depending on where my part's found, I want to be able to move my tools to look for something to move with the part. Ooh, wouldn't that be awesome? So when I take a look at this, I have already done the first step. Okay, I've already found my part. So now what I want to do is I want to find out, see if there's that gouge in there. So what is a histogram? A histogram is basically a distribution graph. You have things that are written on the horizontal axis of saying what you're actually breaking it up into, and then the vertical axis is how much of each. So at one point in my life, if you did my pets, I could have broken them down into dogs, cats, iguanas, and snakes, and I would have had 8 cats, 2 dogs, an iguana, and a snake. So, you know, all these pets and everything like that. Well, that's really what a histogram for the vision tools does, but instead of it being animals, it's grayscale values. So on the horizontal axis, it's 0 to 255 being your grayscale values, and then how many of each are at that number. Okay, because unless you have a created image, you're always going to have some varying in your grayscale value. It's just going to be, even if I take a gray sheet, put it underneath the camera, there's going to be some light fluctuations on it. So that's what we want to take a look at. We want to take a look at how everything's working there. So here are some extract histogram examples. Now you might want to say, well, why would I use a histogram? Well, it's great for presence absence. Is something there, is something not there? It's also really good for checking the illumination levels. Very often customers will put it off to the side where the part's not, or they don't have any pixels or something going on in that area, and they basically monitor what the average light level is. Because as the light starts to degrade over time, maybe you want it to let the PLC know, whoa, light's getting too low, so that you can be more proactive about switching it out until the light gets so low that it actually starts affecting the vision tools. And then at that point, you're kind of at a stop work. It's also great for the uniformity of gray values. So when you're taking a look at them, you can see, is that really just, you know, like some dust there or some scratches, or what's going on in that area? So once again, we are going to put a descriptive comment inside our program because we're good little programmers. And then what we want to do is go over to the histogram tool, grab the extract histogram, drag it, and drop it into the spreadsheet. Now the extract histogram's property sheet's pretty small. It's going to ask us what image do we want to use. It's probably going to want to use A0. It's going to ask us about fixturing. I'll get to that in just one moment. It's going to ask us what region. So what region are we looking for those histograms in? And then it also has this thing called external region. We haven't talked about that yet, but it allows for you to bring in a non-rectangular region. We actually don't touch upon them in class anymore, but they're the composite region, the edit polygon, edit circle, something other than a rectangular region, which the rectangular region, even though we can curve it, it's still what the tools use by default. And then we have show. What do you want to see? So when I take a look at it and I put my region for my histogram right there where there is nothing, what you'll notice is, in this case, I've got a few pixels right down here, then a whole bunch shift right up. That's because I'm down in the brighter end. It's seeing that most of my pixels are probably right around 255. In fact, at some point, it gets up to 1760. Gets up to 1760 pixels have the grayscale value of 255. Now notice what happens if I now have that gouge in that area. What you're going to see is you're still going to basically see some pixels sitting over here, but it's only going up to 565 now. And then I also see some of this. What's that stuff to the left-hand side? That's the dark area. That's the gouge coming in. Those are those darker pixels showing up. Well, what do we get out of it? Well, what it's going to give out of it is it's going to create you a threshold. So it's going to decide what the best threshold is. Anything above that threshold is considered bright pixels. Anything below that threshold is considered dark pixels. So the number of bright pixels is how many pixels are above it. Number of dark pixels are how many are below it. And then your average is going to be what's the average grayscale of them all. Now you might say, but Bonnie, you skipped one. Yes, I skipped contrast. Because I find contrast is easier to explain if I go back a slide. What contrast says is give me what my average dark pixels are and give me what my average bright pixels are and what's the difference between them. So if this is what my mean is over here, my average dark would probably be right over here, and my average bright would probably be right over here someplace. So what's the difference between them? Very, very low. Very low. It's because they're almost going to be almost the same thing. So when you have a solid color, your contrast is going to be very, very low. Not much difference. Now if I look at this one, which has light to dark transition in here, this might be my average dark. This may be my average bright. What's the difference between those? Huge. So basically contrast is letting you know when do you have light to dark transition in that area. If you have a flat color, doesn't matter whether it's all black, all white, all gray, doesn't matter. Just if you have a flat color, it's going to be very low contrast. If you have alternating colors in there, it's going to start bumping it up more. So right now, if I were to put my little histogram tool on it to look for that gouge and all of a sudden move things around, uh-oh, what happened? It didn't move. I created a static region. So as I move my tool, region doesn't move. It's always looking at that point. So what I want to do is I want to create a dynamic region. And I create a dynamic region through fixturing. And basically the fixturing is saying, okay, tell me where in your program do you decide where the part is. So what did we use in our program to decide where our part was? Pattern tool, right. We're getting row, column, and angle back from it. So now what I can do is I can feed that to the fixture. So as it moves, so doesn't the region that I'm using. Now you don't have to use row, column, and angle. You don't have to use all three, but that gives you full fixturing. Like if you're just, if you've only got something kind of moving left to right on your field of view, because everything else might be mechanically fixtured, you might only need column at that point. You know, where does your column start? But for our case, since we have full maneuverability in there, we're going to do row, column, and theta. Theta just means change in angle based off of our Find Patterns tool. So in order to do that, what we want to do is we want to open up fixture, double click on row, and then choose the row, column, and angle results coming back from the Find Patterns tool. Please choose it in that order. Guess what happens if you choose it in the other order? Angle, column, row. Populates it backwards. So now your row's tied to your angle and your theta's tied to your row. Chances are horrible things are going to happen at that point. So now you ready? Wait for it. Wait for it. Oh, moves with it. We need to decide whether our part is good or bad. Now what your lab's going to do is it's going to ask you to put a good part underneath there and check what the average and the contrast is. Then put a bad part underneath there. Check what the average and the contrast is. And see which one changes more. Now the chances are, because if you make your region kind of small and you have such a big gouge in there, you're probably going to see a big change in both of them. But what starts happening is if you just have like a little gouge in there or something like that, you're going to see that your contrast is going to react more violently than your average will. So just a few pixels can throw off your contrast, where the average, it might suck it up and it thinks nothing of it. So what we're going to find is that our contrast is going to be the point at which we're trying to decide whether it's good or bad. And so what do you think a good logic function to decide whether it's good or not would be? If. So in this case, it's saying that if the contrast is less than 50, does that sound right? Remember, we said if it was a flat color, your contrast would be low. If it's contrasting color, then your contrast is going to be high. So yeah, we actually want low here. Now, depending on your application, how bright your light levels and stuff, 50 might even be a little too high for you. You might need to lower that down a little bit. But for what we're doing, 50 works for what we're doing. So beautiful. We got logic up to just say whether it's just a flat surface or not. Or I should say solid color or not. So before I go into the edge tool, let's go ahead and do the histogram while it's still fresh in our minds. And then we'll go on to the edge. So what I want to do is first I want to make sure I'm not in online mode anymore, because I can't type into the spreadsheet if I'm online. So I'm going to drop down an extra row here, and I'm going to say check for gouge. And say OK. And give it a little background. Beautiful. So the tool that I want to use for that is I'm going to go up to my histogram tool. Now I don't freak out when I open it. There's a whole bunch of stuff. Okay? The one that I want is the extract histogram. All these work upon a histogram. And it's just other ways of kind of dividing things down. Sometimes you can just look at a very small array of values. All that I'm going to do is just extract histogram. So I'm going to drag and drop that over here. So what image do I want to use? A0. I'm going to leave fixture alone right now, and then I'm going to double click on region. So my region, I'm going to take this and basically, let me spin it just a little bit. I'm so bummed out because I used to do a really cool little joke in this class, and I can't do it anymore. It doesn't make as much sense. What I used to do is, see, I still have the rotation and everything, and I still have the movement, but this one actually has this bending. So I could bend my item. Yeah, and I could have Pac-Man. I mean, I guess I could make him a little bit shrink here and maybe spin him a little bit. Oh, get back down here. And then maybe like just put him like here. It'll pick up the gouge. So let's say I have my little Pac-Man and I just say OK. So Pac-Man's sitting there. Not using an external region. My options are input graphics, which is the actual region, or input and chart. Now there's my chart right there. If someone knew what they were looking at, that would probably be fine, but if they didn't know what they're looking for, the chart would just be getting in their way. So I'm just going to say input graphics here. Okay. Once again, I will go in and I will just do that little trick before format cells just to make the graphics a little bit bigger so we can see them behind the scenes. So right now, if I take a look at it, my contrast is about 5.8, and my average is about 113. Okay? So let's go ahead and go online. So as I go online, notice that even with our lighting, because we have some fluorescent lights in here, it's not really affecting it that much. Okay? But watch what happens if I move my part right now. Uh-oh. Oops. So what I did is I haven't fixtured it yet. Okay? So what I need to do is I need to go back and fixture. So I'm going to go back into my histogram tool, open up fixture, double click on row, and choose row, column, and angle coming back. So keep the left mouse button down, pull over, drag over, and pull these three in so I can accept. And now you'll see that it's referencing E12, F12, G12. Okay? But you see the numbers over here too. So you kind of have warm, fuzzy feelings. Am I picking up the right numbers? Beautiful. So now if I say OK, let's go online. And now you'll see it move just a little bit because that's just fine patterns. It's not as accurate as like PatMax is, so it moves up and down just a little bit. But now if I move my part, it's moving with my part. Wonka, 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 wonka. Okay? So now if I take this out of the way and put this in, and ta-da! Okay, so I had about 5.8, and it was 118. Let's see what this is saying. So now my contrast went from 5.8 up to about 90, and my average just went down a little bit. It went from like, was it 118 down to 86. It was a bit of one. I mean, I've got quite a bit of black in there. But notice that what was the more dramatic change? My contrast, exactly. So I want to just stop for a moment so that I can come over here and put in logic. So put in a comment called logic. Say accept. Give it a little background. And then what logic statement am I going to use? If. Yep. And this is another reason that I'd use if is we still have a one-sided function here. I can't go below a contrast of 0. Okay, so there's no reason to use in range yet. So I'm going to choose my contrast. I'm going to actually say greater than 50. So if it's greater than 50, what should the true value be? So if it's greater than 50, this would be a 0 because I'm actually reversing my logic here. But what I'm trying to show you here is okay that I reverse my logic as long as it results in being the same results here. So now if I take a look at it, right now it's saying it's bad. Should it be bad? Yeah, I have the bad part underneath it. Let me go ahead. So now I take that out, put this back underneath it, and now sure enough, little Pac-Man is off and running again, and I now have a logic of 1. So now I want to go on, and I want to show you guys one of the edge tools. And in particular, I'm going to show you guys the Find Segment tool. So we've already found our part, and now we've already checked to see if the gouge is there. So the next thing we want to do is we want to determine what's that width of the part. So we're going to use Find Segment. Find Segment is one of the edge tools. So what edges do is they look for light to dark or dark to light transitions. This can either be a circle, an arc, a straight line, multiple lines. So that's what's looking, just for light to dark or dark to light transition. So here are some edge applications. What are edge applications used for? Well, they're great for gauging, so measuring how big the part is. They're also good for finding circle features, because like when you try to find a circle, it's going to give you what the radius of the circle is as well as what the center point of the circle is. It's also great for quickly locating parts. What tool are we using right now as our location tool? Our patterns tool, our Find Patterns tool, but it takes a while. Edge tools usually take in less than a millisecond. So sometimes if you've got some type of mechanically fixture thing that's just going left to right or right to left, using an edge tool might be ideal. Or just 2 edge tools together. You know, where's it going left to right, right to left, where's it going up to top to bottom? Have those come together and get your fixturing tool from there. 2 milliseconds as opposed to like the 20 milliseconds that Find Patterns might give. And it's also good for determining your relative contrast. So instead of looking at the drop from 0 to 255, it normalizes it to something from 0 to 100. So the particular one that we're going to look at is the Find Segment tool. And Find Segment tool is looking for edges that have opposite polarity. Now, what's polarity? Opposite. Is polarity in the sense of an edge tool is, am I going light to dark or dark to light? That's the polarity for an edge tool. So when I'm looking for opposite polarities, one's got to be light to dark and the other one dark to light, or vice versa. Whatever that color, that center is, that's going to be the color of your segment. So if you're going from dark to light, then to dark again, the color of your segment will be white. So we're going to go and add this to our spreadsheet. We're going to create a descriptive comment because we're good little programmers. Then we're going to go over to the edge tools. We're going to open it up and not freak. Yes, there are a ton of edge tools, but they're all alphabetically ordered. So we're going to look down about midway down. We're going to find the Find Segment tool, drag and drop that into our spreadsheet. So what we're going to end up with is a nice little property sheet that's going to ask you what image do you want to use. It's also going to ask you about your fixturing. And it's also going to ask you about your region. So where do you expect to find those edges? And I'll go into regions a bit in a moment. The segment color, we've already talked about that. What color is that center color there? Widest segment, you have your find by. You can either be the widest segment, the narrowest segment, the widest contiguous segment, or the strongest segment. So it's going to look for what your strongest edges are. Your accept threshold. When I show you the graph, the accept threshold is going to make a little bit more sense, but you basically have to cross that relative contrast to say whether this is an edge or not. A normalized score just gives extra emphasis to low contrast edges. We also have angle range. Angle range says if I have an edge that appears inside the region, can that edge have a little bit of range in there? Can it actually have a little bit of rotation? Or am I going to assume it's perpendicular within my region? And then finally, the edge width is how many pixels does it take to go from light to dark or dark to light? And then finally, we have our show. What graphics do you want to see when you are off the tool and online? So what we want to do is we want to put our edge across our region that we're looking for. We want to make sure that the edge that we're looking for is perpendicular in the region. Because basically, you're going to be given a little arrow here. And it's basically saying, okay, I'm going across this region looking for edges. So it says, pow, I find one there. Keeps going across, pow, I find one there. Now, if I take a look at my actual graph, you'll notice that it has these 2 lines right here. That's your accept threshold. Okay, so right now my accept threshold is at 25. It means that if at least I have a 25% color change between my light to dark or dark to light, then it's going to peak above those lines and I'm going to detect that as an edge. Otherwise, notice like these little smaller ones, which is kind of noise behind the scenes, we're not picking that up. We're saying you've got to at least break my threshold for me to consider it an edge. Do you think it matters if it's positive versus negative peak? All that tells is polarity. Positive means you're going from dark to light. Negative means that you're going from light to dark. That's all that it means. Now, our arrow needs to be perpendicular to the edge being found. Because if we look at the top one, notice how we don't really get any graph in there. It's just all hanging around the center line. Because what it's doing is it's going down, it's never finding an edge. It's running parallel to the edge that you're looking for. So it never gets seen. But if I rotate it 90 degrees and then I start going across, bam, finds that edge, and it shows me on my graph, bam, edge found. Now your color, remember, whatever that center color is, if I'm going dark to light, then to dark again, my center color is white. So I would set it to white. If I was going light to dark to light, then my center color would be black. So I'd set it to black. And the results it's going to put out will be the distance in what units? Pixels. We haven't told it anything about real world coordinates yet. So it's going to be in pixels. And then it's going to give you a score. Now, do not freak out by the score. Do not consider the score anything like PatMax score. All that the score is it takes both your light to dark and your dark to light edge, so both of the edges, it does the absolute value and averages them and gives you back what it looks like. So they're basically saying that your edges are doing about a 33% change in color. The higher that score is, it just means a more drastic change in color it's doing, that's all. So if you've 40 is good too. Okay, you got to think of your image. This is not one of those that it's like, oh, if it's 100. If it's 100, it means you had a binarized image that you went from light to dark. Now, what do you think a good logic tool for this would be? In range, excellent. Now, why didn't we use an if? Well, the thing is the reason we did the ifs before is we had one side that was always nailed down. Like score, we can never go over 100. It can never go back to being bad. Contrast, we can never go below 0. You know, you can never go past that. But with my distance, I can be higher or lower. So I'm going to want an in range because I can actually be bad on both ends. So I want to make sure that I put what my high value is and my low value is. Now for us, we're going to make up what these values are because we haven't calibrated it yet. So I have no idea what they should be. So we're going to basically say, hey, what's our bad part? What's our good part? What's the difference between them? Whatever that difference is, kind of half it, and roughly use that as a plus or minus around the good part. When we get to the calibration, then I'm going to do plus or minus percentage, because I know what my part should be spec'd as. But for pixels, yours is going to be slightly different than mine. It completely depends on what the camera is with regards to the part. I even have mine pushed back a little bit because it kept falling over. So mine's even skewed within my image. So we have two groups of edge functions. We have the functions that find edges, as well as the functions that work upon the edges found. Now, some of the things that find functions, that find edges, are like find line, which finds a line. Then we have find multi-line. I bet you don't know what that one does. It finds multiple lines. Amazing that. What about find circle? It finds a circle. So yeah, so we've got a lot of different ones that find it. We also have this like find circle min-max. That not only does it find your best fit circle, but it will also tell you what your nearest most point and your furthest most point is. And it shows them as little dots. So you kind of know where you have deviations. Now, some of the things that operate on edges. Basically, all these functions operate on find multi-line, because you need more than one edge for this to work. The only other function that uses this is find segment, which uses a pair distance, because you need multiple edges for these to work. So it does things like pair distance, just finds the distance between two pairs. Sorts edges, puts them some type of sorting mechanisms for it other than the normal. So we talked a little bit about extracting the histogram. We talked about how it gave us statistical information about the grayscale values that are sitting inside the region that you've given it. We talked a little bit about fixturing. We showed how you can actually have your region of interest of your tool move as your part moves. And then we went on to find out that full fixturing we could get from row, column, and angle. And then we talked a little bit about edges. And we talked about the edges that find lines or curves or circles or whatever. And then we have the functions that operate on them, such as pair distance, that's going to give me the distance between two separate pairs. So let's actually try this out. So I've already done my histogram tool. So now what I want to do is I want to check the distance of the part. So measure block length. That sounds good. Except, give myself a little background. There we go. So the edge tool that I want to use here is going to be Find Segment. So that's going to be found underneath my edge tools. If I open them up, about midway down, Find Segment. Like I said, don't freak out when you open these up. There's a ton of functions in here. It is all alphabetical order. Find Segment, I'm going to drag and drop that in. Beautiful. Now, what image am I going to use? A0, exactly, the acquired image. Fixture. What are we going to do for fixturing? So it's going to be the same fixture as before. So I'm going to double click on row, choose my row, column, and angle, coming back from my Find Patterns tool. So same way we did the histogram. So everything's going to be fixturing on that Patterns tool. Now my region. So if I open this up, here's my little tool, and I can see that I have my arrow. So I'm going to go from about right here all the way over to about right here. Now, why do you think I don't want to do this? This is going to throw me off a little bit, yeah. So I probably don't want to do that. Now, do you think it matters if I make it, well, one thing I should comment is, so often I see people when they do edge tools, they get it right to the edge. Yeah, that'll find my edge. Yeah, that's perfect. What's the problem here? You need a transition, but what if all of a sudden it's a little bit closer to the camera? Now you can't find your edge. So with edge tools, it's always important to go past what you're looking for. Give it a little bit of leadway. Go a little bit past it. Now the other thing that you could do is I could either do it kind of fat or thin. Do you think it matters whether it's fat or thin? It's going to be easy to detect the edge anyway, but an averaged. So what ends up happening, the narrower you have your edge region, the more susceptible it's going to be for small deviations in that field. Let's say you have a serrated knife. So if I have a pretty fat edge looking over my serrated knife, what it's going to kind of do is kind of average all the little teeth together until it kind of gets that average there. But if I make it really small, if that just happens to be where one of the teeth is, it might get pushed in a little bit versus is it one of the valleys. So if I kind of have a rough edge, I might want it a little bit thicker to average it, unless I'm trying to pick up just little deviation points. So I'm going to make it just a little bit bigger. You know, I'm going to try to avoid the dots only because make my life easier. And I'm going to go ahead and say OK right now, and sure enough, it's sitting here. I can see on my graph, it just breaks my threshold. Okay, but I'm not seeing any graphics yet letting me know that I have an edge. Okay, let's keep going then. Well, what's my segment color? Is white, exactly. So as soon as I turn to white, notice that if I turn this off, I now see a 0 and a 1 here. Why a 0 and a 1? 2 lines, exactly. And the reason that my 0's over here is it goes in the order of the arrow. If I rotated the arrow 180 degrees, my 0 would be on my right side, and my 1 would be on my left side. I'm going to go ahead and do widest segment. That looks good. My accept threshold, since that catches this, that's fine. But if I look at my graph, I can tell that it's a little tight with it. So, I mean, I always could just in case I have a little bit of busier stuff going on, I could just do it down to 20 now, and notice it catches it just a little bit better. Since none of my noise is coming up to there, I'm fine with it. But if I had some swing, then maybe I wouldn't. Everything looks good. I'm not worried about my angle range. I'm not worried about my edge width. Beautiful, beautiful, beautiful. My results, graphics only, are going to be my lines. Input and result graphics are going to be my input region and my lines. And show input, result, and chart. Once again, do I think someone really wants to see the chart? Probably not. So let me go ahead and say input and result graphics and say OK. And sure enough, what it gives me back is the distance in what? In pixels. Give me the distance in pixels. So now what I can do is I can come over here to my logic. Let me just put in the word logic real quick. And let's see what the difference is between my good part and my bad part. Okay. So my good part is 812 pixels. Let's put my bad part underneath here. Acquire. And my bad part is 873. So there's about 60 pixels difference. So if I say plus or minus 30, once again, we're not doing rocket science here. It's just, 60, 30. If I'm looking at 120 pixels, then a low value might be 790, a high one might be 850. So for my logic, I can go down, pull my in range, say what value am I looking for? I'm looking at my distance. So my low value might be like 790. My high value might be 850. Yours might be slightly different, so don't worry about that. And then sure enough, it's letting me know that I have a bad part right now. Is that correct? Yeah. So what I can do is let me go ahead and go online, bad part, bad part, bad part. And now let me push this over, and sure enough, we're getting a good part. Now, I want to show you guys something kind of cool. It's not in the lab, but I was just thinking about this. This would be a cool time for me to show it. What if I did want to see that graph for some reason, that I did want to pull it up, but I wanted to interactively pull it up? Catch this cool thing. If I open up my edge tool and I take my show and I drag and I drop it right there, it puts the word show in, it puts this information in here, and it references it to the cell. Because watch this. So if I'm going online, it's showing me my graphics back there and everything. But then I can also just say result graphics only. And now it's only showing me just my lines right there. You can barely see them. I'm going to have to make them fat. Or I could say, give me the chart. And sure enough, there's my chart. Ooh. And then I could just also hide them too. And now I have no graphics shown for it. Still running, still getting information. I'm just not showing any graphics for it.